So similar to the previous sum, here what we have is exactly what we did before. Okay, so in this one, this is given, cos A plus B is given, and we have to show that cos twice A is this. Okay, so if we do this for A, it is going to be left hand side, cos twice A is going to be A plus A, so equals to cos minus sin. So this is going to be cos A minus sin A. So they're same, cos theta, they're the same angle, so this is cos square A minus sin square A, but of course we have to prove in terms of cos square this time. So we know that instead of sin square we can write 1 minus cos square, so I can write cos squared A minus 1 minus cos squared A. So if I remove the bracket, cos squared A minus 1 minus plus cos squared A, this is going to be 2 cos squared A minus 1. So therefore the left hand side is equal to the right hand side, and it has been proved, QED. Now in the next part we have to show cos 4 theta. Okay, so left hand side is cos 4 theta, so we were going to write cos 4 theta is 2 theta plus 2 theta. We always want to involve 2 theta. If it was cos 3 theta, we are going to write theta plus 2 theta. If it is 4 theta, it is 2 theta plus 2 theta. There is not going to be sums cos 5 theta or 6 theta. Is going to be confined to 3 theta and 4 theta. So this is going to be, we know it's going to be cos minus sin. So this is going to be cos 2 theta minus sin 2 theta sin 2 theta. Now here, since both the angles are same, cos 2 theta and cos 2 theta, they're identical creatures, they're the same, so we can write cos squared of this angle minus sin squared of this angle. I've mentioned that if the same thing are multiplied, we write sin square of any angle or cos square of any angle. Now what we have to express, again we have to express in terms of cos square, so we have to break this down. So cos squared 2 theta is the same as breaking this down as 2 cos square A minus 1. We're going to follow the guidance of the question, so we're going to follow that. So we can write cos 2 theta as 2 cos square theta minus 1, and this whole thing is squared, so this is squared. So 2 cos squared theta minus 1 squared. Of course they used A here, and here they're using theta. That's fine, completely fine. Minus sin squared theta. Sin 2 theta is 2 sin theta cos theta, and we're going to square it because there is sin squared theta is the same as whole squared. Sin squared x is the same as sin x whole squared, is the same thing. So we can say that this thing and sin x whole squared, they're the same thing. So here we can use the algebra of a minus b whole squared. So a minus b whole square is the basic algebra rule, which goes like this: a minus b whole squared is a squared minus 2ab plus b squared. So this algebraic concept can be used. For that case, a squared is going to be 2 cos squared theta whole squared minus 2ab. So 2 cos squared theta is, this is a, and b is 1, plus b square plus 1 square, minus, and this portion 2 sin cos whole square is going to be 2 square is 4, sin square is sin square, cos square is cos square. This is what it's going to be. So this is 2 cos square theta whole square is going to be 2 square is 4, cos square square is going to be cos to the power 4 theta. Remember, not on the angle but on this, that's where the power is going to happen. So 2 to the 4, and cos square theta is going to be cos square theta plus 1 minus 4. Now everything is fine except for this sin square theta, so we have to make it cos square theta, because in our proof the identity has to be completely cos in terms of cos. So we know that instead of sine square, we can write 1 minus cos square, so we can write 4. Let me write the cos square theta ahead, and instead of sine square theta, let me write 1 minus cos square theta. So what do we get now? So we are getting 4 cos to the power 4 theta minus 4 cos square theta plus 1 minus 4 cos square theta into 1 is 4 cos square theta minus minus plus 4 cos square theta into cos square theta is going to be 4 cos to the power 4 theta, and the final line is going to be, we need 8 cos to the power 4 theta, so 4 cos to the power 4 theta plus 4 cos to the power 4 theta, 4 plus 4 is 8 cos to the power 4 theta, and we are going to get minus 8 cos square theta minus 4 cos square theta minus 4 cos square theta is going to be minus 8 cos square theta, and finally there is a plus 1, so we're going to write here plus 1. So therefore the left hand side is going to be equal to the right hand side. So this is how the proof is done. So very similar, this is a very common question that we can see. Now the next sum that I want to look at is a bit different. This is a bit new. So the next sum is of course similar, but there is something new here. So this is given and we have to do this part. So this particular sum is going to start like this. Let me position it here. Okay, this particular sum is going to start like this. The A is going to be, we have to prove cos A plus B plus cos A minus B is identical to 2 cos A cos B. So let's take the left hand side and write down the question. Cos A plus B plus cos A minus B, and if we break it down, it's going to be cos A plus B is going to be cos A cos B minus, because if there is a plus we have to write minus, sine A sine B, so this is going to be one thing, plus, and cos A minus B is going to be cos A cos B. Since there is a minus we have to give a plus, plus sine A sine B. So if we add it up, this thing minus sine A sine B and plus sine A sine B cancels, and it is going to be 2 cos A cos B. So therefore the left hand side has been proved to be equal to the right hand side. So this has been done. This was fairly easy. Now the next one is the same thing. We know that cos 2A is identical to 2 cos square A minus 1. So I'm not going to do number B, I'm directly moving to number C. So number B I'm not doing, I'm just saying to prove cos 2A, it can be proved as 2 cos square A minus 1. So let's move on to number C. In number C, what's happening is, this is completely new, so this needs to be paid attention. For this sum is important. Look at this. In the previous sum it was cos some sort of an angle plus cos of another angle is 2 cos cos, and it looks the same. Cos some sort of an angle plus cos some sort of an angle is 2 cos cos. So they're similar, so there is something in common, so we have to use this sum to prove this sum. So these two sums are interconnected. So how this can be done? The first thing that we have to do, we have to start with, let's start with, since this is cos A plus B and this is cos P, so let's start with, let A plus B equals to P, equation 1, and the next one is A minus B, and this is Q. So if you take a look here, P is the position of A plus B and Q is the position of A minus B. So we can have an equation and say A minus B is equals to Q. So this is equation 2. Now if we add the two equations, if we add equation 1 and 2, what we get, a plus a is twice a, minus b plus b cancels off, and we get p plus q, and from there we get a equals to p plus q by 2. So we find a value of a, and similarly by putting this value we can find the value of b. We know b equals to p minus, if we send the a to the other side, p minus a, and the value of a is p plus q by 2. The bracket is very important because this is a unity whole thing. So if you take the LCM as 2, p into 2 is 2p, minus 2 into 2 is 2 ones are 2, so bracket is p plus q. So if we remove the bracket, this is going to be 2p minus p is going to be p, minus into plus q is going to be minus q. So we are going to get p minus q divided by 2. So now we have the value of a and the value of b. So if we move on, we can write, we know that cos a plus b, which we proved in a, we know cos a plus b plus cos a minus b, let me remove it, is identical to 2 cos a cos b. Therefore cos in a plus b we can write p, because we have said a plus b is p, plus cos a minus b we can write q. It's equals to 2 cos a. Now the value of a that we found was p plus q by 2. This is the value of a, and the value of b we found was p minus q by 2. So this is going to be, this is cos p plus q by 2 cos p minus q by 2, and therefore proved. Left hand side equals to right hand side. So this has been proved. Now the final one, the last question was, after it has been proved, hence show that cos 8x plus 2 cos 6x plus cos 4x is. So hence means we have to use the previous sum, cos p plus cos q, and we have to prove this one. Now let's do this. Let's do this over here. Okay, let's do it over here. So this is number D. Now the first thing we have to remember, we need the left hand side is cos 8x plus 2 cos 6x plus cos 4x plus cos 4x. If you take a look at the previous sum was cos p plus cos q can be written as 2 cos p plus q by 2 cos p minus q by 2. That means if we have a cos and an angle plus cos and another angle, we can write it. This is some sort of a new formula, a sort of a new formula for cos. This is a new formula for cos, we can consider it. So we see that this thing can be considered as cos p and this thing considered as cos q. So we can think of this as p and think of this as q. Why not this one? Because there is a 2 here. For that formula to work, it should be free. So using that, we can write cos p plus cos q is 2 cos p plus q by 2, p plus q by 2, 8x plus 4x by 2. So 8x plus 4x by 2, and cos p minus q by 2, which is 8x minus 4x by 2. We can write it, and we have cos 6x, this is left, so plus 2 cos 6x is left. Okay, so now we can write cos 8x plus 4x is 12x by 2 is 6x, so 2 cos 6x, and cos 8x minus 4x is 4x, 4x by 2 is 2x, cos 2x, plus we have 2 cos 2x plus 2 cos 6x. Now we can take 2 cos 6x to be common. We can take 2 cos 6x to be common, and we get cos 2x plus 1. Now it has been given in the just the previous sum. We didn't prove it, but it is cos 2 theta is 2 cos squared theta. Theta is any pronoun, we can call it a, theta, anything, minus 1. So we know this one. So we didn't know why they gave it. It was part of the scheme. So now we know why that thing was given. So we can write 2 cos 6x. So instead of cos 2x we can write 2 cos square x minus 1, and we have this plus 1 from previous line. So in the final line we have 2 cos 6x. This 2 and this 2 becomes 4 cos 6x, and this one and this one cancels, so we get cos square x. So we had to prove 4 cos 6x cos square x, and this has also been proven.